Welcome to This Explainer. Today, we're diving straight into a classic tech mystery. We are going to focus on the absolute unsung hero of computation, the parser. What exactly is a parser? How does it actually work? And, maybe most importantly, why does it get blamed for literally everything that goes wrong?
Okay, let's dive into this. Picture this. You're staring at your screen, there's this massive glaring red syntax error or invalid input message staring right back at you. First instinct, you check your code, you double-check your data, and you immediately think, man, this parser is completely broken. We've all been there, right? Pointing the finger directly at the tool that's throwing an error right in our face.
But here's the big plot twist for today's explainer. As this quote hits right on the head, the parser is usually completely innocent. Honestly, most of the time, the parser itself is perfectly fine. It's doing exactly what it was meticulously engineered to do. The real problem? The entirely wrong parser got called to do the job. The actual culprit is usually hiding upstream in a silent, invisible layer called the router.
To really understand what a parser is and why this happens, we kind of have to look at the basic anatomy of how systems process input. Every system follows the simple three-step pipeline. Starting over on the left, step 1 is the input. This is just your raw, uninterpreted data, a text string, a file, a voice recording. It literally has no inherent meaning yet. Step 2 is the router, which is basically just a decision layer. And finally, step 3 is our main focus today, the parser. This is the understanding layer. Your raw data means absolutely nothing until it successfully passes through these checkpoints.
Let's ground this in a real-world scenario. Imagine a restaurant. A customer walks to the front door speaking French. That customer? They're our input. The restaurant host is the router. They hear French, and they decide to seat this customer in a section with a French-speaking waiter. That waiter is our parser. The waiter takes those French words, actually understands their complex meaning, and successfully takes an order for a coffee. Input, router, parser. Make sense?
Now, let's contrast how things break down here. A routing error is like our host seating that French-speaking customer with a Japanese-speaking waiter. The waiter hears French, doesn't understand a single syllable, and fails. But the waiter, our parser, isn't broken. They were just handed the wrong customer. On the flip side, a true parsing error happens if the customer sits with the French waiter but tries to order a flying coffee. The waiter understands the language perfectly, but the request itself is just hilarious nonsense.
Let's formally define these roles. First, the router. The router is essentially a dispatcher. It asks one really basic question. Given this input, which parser should I send this to? It does not understand the deep content of your file. It just looks at really shallow surface-level signals, like a file extension ending in .json or an HTTP content type header.
Now, in stark contrast, let's look at the parser. A parser is an interpretation layer. This is the part of the system that requires deep, meticulous knowledge of grammar, schema, and structure. It expects data to arrive in a highly specific format, and its entire reason for existing is to extract meaning from that correctly routed input. A parser is an absolute specialist. If it expects JSON, it parses JSON beautifully. But if you hand it XML, it's going to loudly throw an error because it cannot extract meaning from a format it wasn't built to read.
And this brilliantly illustrates the separation between the two. The router has a broad scope, shallow knowledge, moves incredibly fast, and fails completely silently just by sending things to the wrong destination. The parser, meanwhile, has a really narrow scope, deep structural knowledge, is slower because of the complex analysis it does, and fails very, very loudly with explicit error messages. We blame parsers precisely because they're the ones making all the noise.
Moving on to Section 1, the evidence. Let's look at some real-world tech fails.
Okay, imagine you have a text file with some JSON data. If you name it data.json, your operating system's router sees that .json extension and sends it straight to a JSON viewer. The viewer parses it into a nice structured tree. Perfect. But what if you take that exact same text file and rename it to data.exe? The OS router sees .exe and dispatches it to the system loader, which tries to parse your text as executable machine code. The result? Boom! Immediate system crash.
So you get this massive error pop up on your screen. Is the OS loader broken? No. It's doing exactly what it was built to do, parse executable files. This is a classic routing error because you sent JSON data to an executable parser. The error is super loud, sure, but the parser itself is entirely innocent.
You see this in command line interfaces too? Say you want to check your code history, so you type git log. The shell routes you to the git parser, which understands log.
But what if your brain glitches and you type Docker log by mistake? You're going to get an unknown flag error because you passed Git arguments to Docker. So is the Docker parser broken? Definitely not. The router correctly sent your command to Docker. This is a human routing error. You literally routed your own intent to the completely wrong parser.
Compilers fall into this trap all the time. Write some Python code, save it with a .py extension, the Python router sends it to the Python parser, and it works flawlessly. But take that exact same Python code and save it as main.rs, a Rust file. That file extension routes it to the Rust compiler. The Rust parser takes one look at your Python syntax and just violently rejects it with a massive syntax error.
Once again, we gotta ask, is the Rust compiler broken? No. You sent Python code to the Rust parser. The parser was just doing its job, desperately trying to find Rust grammar where there was absolutely none. It's a classic routing error masquerading as a parsing failure.
Let's look at natural language processing, like your smart voice assistant. If you say, set a timer for 5 minutes, but the device misses the wake word, the audio router just discards it. Nothing even reaches the NLP parser. That's a routing failure. But if it does catch the wake word, and you say, set a timer for banana minutes, the parser receives it, but fails because banana obviously isn't a valid number of minutes. Now that is a true parsing error. The input genuinely didn't fit the expected grammar.
All right, let's jump to section 2, the diagnostic checklist.
So, how do we build a detective's toolkit for this? Next time you hit an error, ask these 5 things. 1. Is the input format actually what the parser expects? 2. Are the routing signals, like file extensions, correct? 3. Did a proxy or load balancer maybe strip away those signals? 4. And this is the ultimate test. If you take the input and test it in a standalone validator, does it work? If it validates in isolation, your parser is completely innocent. And 5. What happens if you manually force a system to use a different parser?
So the crucial point here, the one thing you should take away from this, is to stop and ask, did the right parser even get called? Truly understanding what a parser is and how it differs from a router completely transforms debugging from random guesswork into a systematic investigation. Before you dive into the code to rewrite an entire block of data just because the parser yelled at you, just pause. Checking your routing signals first is going to save you hours of wasted time.
The next time a massive syntax error ruins your afternoon, just take a deep breath. Remember the restaurant, remember the waitstaff, and ask yourself who you're really dealing with. Are you going to blame the loud, meticulous parser? Or will you look upstream and investigate that silent, sneaky router? Look past the noise, and you'll completely elevate your understanding of how systems actually process information. Thanks for joining me on this explainer, and happy debugging.